$1,200. That was the dealership quote for a new catalytic converter. A customer rolled into my shop last year, convinced he needed one. I looked at his maintenance history, asked 3 questions, and told him to come back in 2 days. 48 hours later, he drove out. Same catalytic converter, $0 spent. Check engine light hasn't come back since. What I told him takes 20 minutes, 0 tools. Japanese mechanics have been doing it since the 1980s. Your dealership knows this fix. They've known each other for decades. A new converter is $3,000 in labor and parts. This fix is free. Guess which one they recommend. Number 15, the premium fuel flush myth. When the check engine light first appears, the most common advice you will receive from automotive forums is to run 3 consecutive tanks of high-octane premium fuel. People believe that because premium fuel costs more, it contains stronger cleaning detergents that will magically scrub the catalytic converter clean as you drive. We must break down the actual chemistry of petroleum distillation. Premium fuel, usually rated at 91 or 93 octane, music does not contain more energy than regular 87 octane fuel. It is not inherently cleaner. The octane rating simply represents the fuel's resistance to premature detonation inside the combustion chamber. High compression engines require higher octane to prevent the air and fuel mixture from exploding before the spark plug ignites it. When you put premium fuel into an engine designed for regular unlead, the engine computer does not magically run hotter or cleaner. In fact, because high-octane fuel burns slightly slower to prevent knocking, it can actually leave behind more unburned hydrocarbons if the engine lacks the compression to burn it efficiently. Premium fuel contains the exact same federally mandated level of basic cleaning detergents as regular fuel. It will not scrub your exhaust system, it will not repair a poisoned oxygen sensor, and it will not save a glazed ceramic honeycomb. While premium fuel is an expensive placebo, the next method relies on an old mechanic trick that utilizes music, extreme engine speeds to burn away the problem. Number 14, the standard Italian tune-up. Decades ago, mechanics coined a phrase for fixing sports cars that were driven too gently by their owners. They called it the Italian tune-up. The premise is entirely tool-free and requires nothing more than a stretch of open highway and a heavy right foot. Modern commuter vehicles spend the vast majority of their lives operating at incredibly low engine speeds. When you sit in stop and go traffic or cruise at a steady 50 km/h, your engine rarely exceeds 2,000 revolutions per minute. At these low speeds, the internal combustion temperatures remain relatively low. This low temperature environment allows unburned carbon soot, unburned fuel, and crankcase oil vapors to safely exit the engine and stick directly to the front face of the music catalytic converter. The standard Italian tune-up attempts to solve this by intentionally driving the vehicle aggressively. Music. You merge onto the highway, leave the transmission in a lower gear, and hold the engine at 5,000 revolutions per minute for 10 to 15 minutes. The mechanical goal is to drastically raise the exhaust gas temperatures. A catalytic converter normally operates at roughly 400 to 600 degrees C. By sustaining high engine speeds, you force the exhaust temperatures past 700 grillers, attempting to physically incinerate the carbon blockage. However, this method is fundamentally flawed for modern, heavily glazed converters. It only burns off the loose topical soot resting on the front of the honeycomb. It does not possess the chemical energy required to unbind baked-on phosphorus or zinc glazing caused by burning engine oil. Furthermore, if the converter is severely clogged, forcing high exhaust volume through a blocked pipe creates massive back pressure that can blow out your exhaust manifold gaskets. Driving hard only handles surface soot. To cut through heavy chemical glazing, you need aggressive solvents, which leads us to our next highly controversial method. Number 13, acetone fuel doping. This method is passed around in underground racing communities in hyper-milling forms. The hack involves purchasing pure liquid acetone from a hardware store and pouring a specific tiny ratio directly into your vehicle's gas tank before a fill-up. Proponents claim that acetone reduces the surface tension of the gasoline, allowing it to vaporize much more efficiently in the combustion chamber, resulting in a cleaner burn that eventually starves the catalytic converter of carbon soot. Acetone is a phenomenal industrial solvent. It is incredibly volatile and flashes into vapor almost instantly. When you mix it with gasoline, it does technically alter the physical properties of the fuel. However, applying this to a modern computer-controlled fuel injection system is a terrifying mechanical gamble. The catalytic converter is not the only piece of plastic or rubber in your vehicle. Your entire fuel system relies on highly sensitive rubber O-rings, plastic music fuel pump impellers, and flexible polymer fuel lines. Acetone acts as an aggressive chemical attacker against these specific materials. A young enthusiast tried this trick on his 2008 Ford Mustang. He poured half a pint of acetone into a full tank of gas, hoping to clear a pending emissions code. Within 3 days, the acetone chemically melted the rubber seals inside his high-pressure fuel pump. The fuel pump lost pressure. The engine stalled on the highway, and he had to pay $800 for a complete fuel tank drop and pump replacement. The catalytic converter remained completely clogged. Acetone does not survive the combustion music process. It burns up entirely inside the cylinder and never reaches the exhaust stream music to clean the converter. It is a highly destructive myth that targets the wrong end of the vehicle. While acetone destroys your fuel pump without reaching the exhaust, the next historical method attempts to use a different industrial solvent to achieve the same goal. Number 12, pure lacquer thinner ingestion. This hack was popularized by old school mechanics on YouTube and remains one of the most widely attempted catalytic converter fixes on the internet. The instructions dictate that you wait until your gas tank is exactly half full, pour 1 entire gallon of pure lacquer thinner directly into the gas tank, and drive the vehicle on the highway at high speeds for 1 hour. To understand why this is recommended, you have to look at the ingredients of retail lacquer thinner. It is a harsh blend of heavy industrial solvents, primarily toluene, xylene, and methanol. Toluene and xylene are incredibly music-aggressive, high-energy aromatic hydrocarbons. Unlike acetone, which flashes too quickly, these solvents burn with intense thermal energy. When the engine computer injects this mixture into the cylinders, the lacquer thinner aggressively scrubs the fuel injectors. When it ignites, it raises the combustion temperature significantly. The theory is that the exhaust gases become so incredibly hot and chemically saturated that they bake the carbon out of the catalytic converter grid. I had an older customer with a 2006 Toyota Tacoma who swore by this method. He poured a gallon of lacquer thinner into his tank to pass his yearly emissions test. It worked. The check engine light turned off and the emissions testing machine passed his music truck. However, the collateral damage is severe. Modern vehicles utilize complex evaporative emission systems designed to capture raw fuel vapors. These systems rely on charcoal canisters and delicate plastic purge music valves. The incredibly harsh chemical fumes from a gallon of pure lacquer thinner can overwhelm the charcoal canister and melt the thin plastic diaphragms inside the purge valve. You might fix your P0420 code, but you will trigger a massive evaporative emissions leak code a week later. Lacquer thinner is an uncontrolled, highly volatile risk. To safely clean the system, you need targeted automotive chemicals, which brings us to the most famous retail additive on the market. Number 11, the Seafoam motor treatment. Walk into any auto parts store in the country, and you will see shelves lined with classic white and red cans of Seafoam. This product has been around for decades. Originally engineered to clean outboard marine carburetors, the music hack involves pouring an entire can of Seafoam into your gas tank to clear the catalytic converter. Seafoam is a brilliant, simple chemical mixture. It consists of pale oil, naphtha, and isopropyl alcohol. The pale oil acts as a heavy lubricant. The naphtha acts as a crude cleaning solvent, and the isopropyl alcohol serves as a water absorber to dry out condensation in the fuel tank. When you pour this into your gas tank, the naphtha does an excellent job of breaking down soft carbon deposits on the music back of your intake valves and cleaning the atomization nozzles on your fuel injectors. The vehicle will likely idle smoother and accelerate with less hesitation. However, as a catalytic converter cleaner, the fuel tank method is an absolute failure. Seafoam relies on liquid contact to dissolve carbon. By the time the Seafoam mixture is injected into the engine and exposed to the violent, fiery explosion of the combustion stroke, the naphtha and alcohol are completely incinerated. The pale oil burns up and actually creates music, a heavy white smoke. Absolutely zero active cleaning chemicals survived the fire to reach the exhaust stream. A teenager bought an old Jeep Cherokee with a clogged converter. He poured music, 3 cans of Seafoam into the gas tank over a single month. His engine ran beautifully, but the heavy white oil smoke created by the Seafoam, actually music, coated his catalytic converter in an even thicker layer of unburned ash, making the original blockage significantly worse. Pouring Seafoam music into the gas tank cleans the injectors, but suffocates the exhaust. To bypass the fuel tank entirely, mechanics developed the next much more aggressive ingestion method. Number 10, direct vacuum line music ingestion. When mechanics realized that fuel tank additives were burning up before they reached the exhaust, they engineered a tool-free method to bypass the fuel tank and the fuel injectors entirely. This method is known as vacuum line ingestion or an induction service. Every modern engine utilizes a brake booster vacuum line. This is a thick rubber hose that connects the engine's intake manifold directly to the brake booster on the firewall. It uses the engine's natural vacuum to assist your braking power. The hack requires you to pull this rubber hose off the brake booster while the engine is running. You then slowly sip a liquid cleaner, like Seafoam, or a dedicated induction fluid directly from the can using the vacuum suction. Because the liquid is pulled directly into the intake manifold, it bypasses the fuel filter and the fuel injectors. A large volume of liquid solvent hits the combustion chamber all at once. The engine will sputter, choke, and struggle to stay running. When the massive concentration of solvent hits the hot engine components, it creates a chemical steam cleaning effect. The engine will forcefully expel massive, thick clouds of blinding white smoke out of the tailpipe. This violent chemical flush does a remarkable job of breaking off heavy hardened carbon chunks from the piston, music crowns. As these carbon chunks are blown out of the exhaust valves, they strike the front of the catalytic converter at high velocity, potentially knocking loose surface glazing. The danger of this method is hydrostatic lock. If you allow the vacuum line to suck up the liquid cleaner too quickly, the liquid will fill the engine cylinder because liquid cannot be compressed. When the piston moves upward, the engine will violently shatter its own connecting rods, completely destroying the engine block in a fraction of a second. Furthermore, the massive volume of liquid solvent cools down the catalytic converter rather than heating it up, failing to reach the necessary light-off temperatures required for true chemical decarbonization. Induction services are incredibly risky and lack thermal heat. To safely clean the system from the fuel tank, we must use specific chemicals that survive combustion. Number 9, polyobutylene-based cleaners. If you read the back of most cheap entry-level fuel injector cleaners at the auto parts store, you will see a chemical compound listed as polyisobutylene, commonly referred to as PIB. The hack involves buying several bottles of these cheap cleaners, waiting until you have a quarter tank of gas, and dumping them all in to create a hyper-concentrated cleaning solution. PIB was the first major chemical advancement in automotive detergents. It was engineered to prevent soft carbon buildup on the intake valves of port-injected engines. When the fuel sprays over the intake valve, the PIB acts as a detergent shield, preventing raw fuel from baking onto the hot metal. If your vehicle is suffering from a minor misfire due to clogged fuel injectors, this method actually works. By creating a hyper-concentrated mixture in a quarter tank of gas, you force the injectors to spray a massive amount of detergent. Once the injectors are clean, the engine stops misfiring, the air and fuel ratio stabilizes, the catalytic converter stops receiving unburned raw fuel. A customer with an older Hyundai Sonata had a flashing check engine light and a P04420 code. The flashing light indicated an active, severe misfire. He used 3 bottles of cheap PIB cleaner. The detergents cleared a blocked injector, stopping the misfire. Because the engine was no longer dumping raw fuel into the exhaust, the catalytic converter was able to recover and the code disappeared. The reality, however, is that PIB completely breaks down during the combustion cycle. It does absolutely nothing to clean a catalytic converter that is already heavily glazed. It is a preventative maintenance chemical, not a restorative cure. It fixes the engine, not the exhaust. To physically scrub the exhaust system, you need a chemical formula designed specifically for post-combustion survival. Which brings us to the next specialized retail product. Number 8, Cataclean Liquid Carbon Eliminator. This is arguably the most famous and highly marketed catalytic converter cleaner in the world. The bottle specifically states that it clears P0420 codes and lowers emissions. The hack is to follow the instructions exactly. Music, pour it into an almost empty gas tank, drive for 15 meters, and then refill the tank completely. To understand why this product is highly recommended, we must look at the proprietary chemical data sheet. Cataclean is a highly specific blend of xylene, acetone, isopropanol, and heavy aromatic naphtha. You will recognize these chemicals from our earlier, more dangerous hacks. The brilliance of this product is not the chemicals themselves, but the precise laboratory, music, tested ratios. By combining xylene and heavy naphtha, the formula drastically alters the combustion properties of the fuel. It creates an incredibly hot, lean burn inside the engine cylinder. This elevated thermal energy acts exactly like an Italian tune-up, but on a chemical level. The intense heat generated by the heavy aromatics safely elevates the exhaust gas temperatures far beyond normal operating parameters. This heat forces the internal ceramic honeycomb of the catalytic converter to reach its maximum efficiency threshold. As the extreme heat washes over the ceramic grid, the trapped carbon soot bakes off and oxidizes into harmless carbon dioxide gas. I have recommended this product to dozens of customers who were facing immediate emissions testing failures. For vehicles with minor to moderate carbon glazing, it works flawlessly. It safely raises the thermal energy without melting the plastic fuel lines like pure lacquer thinner wood. However, it is not a miracle in a bottle. If your catalytic converter is heavily choked with burned engine oil, known as phosphorus or zinc glazing, the heat generated by Cataclean will not be enough to break the chemical bond. It excels at removing carbon soot, but struggles against heavy oil contamination. Cataclean music relies on elevating thermal energy. The next method targets the root cause of the poor combustion by chemically shocking the oxygen sensors. Number 7, OxyCat oxygen sensor and converter cleaner. Many people misunderstand how a catalytic converter actually music functions. It does not work alone. It relies entirely on the upstream and downstream oxygen sensors. The upstream sensor monitors the air and fuel ratio leaving the engine. The downstream sensor monitors the efficiency of the catalytic converter itself. When an engine burns oil, heavy layers of soot coat the tiny microscopic thimbles inside these oxygen sensors. When the sensors are coated in soot, they become lazy. They report incorrect data to the engine computer. The computer responds by dumping excess raw fuel into the engine, which then travels into the exhaust and suffocates the catalytic converter. The hack is to use a product like oxycat. This is a highly specialized chemical compound engineered specifically to target the lambda sensors in the exhaust system. Rather than just raising the exhaust temperature, this chemical is designed to survive the combustion chamber and vaporize into a highly active gas. As this chemical gas passes over the lazy, soot-covered oxygen sensors, it physically dissolves the resin and carbon deposits, blocking the sensor thimble. Once the sensors are clean, they begin reporting lightning fast, accurate data back to the engine computer. The computer instantly adjusts the fuel trim, stopping the rich fuel mixture that was choking the catalytic converter. This is a brilliant chemical hack, but it only solves the problem if the root cause is a dirty sensor. If the converter itself is heavily contaminated, you need a liquid product designed to survive the fire entirely. Number 6, polyethylene high concentration treatments. If you want an uncompromised chemical cleaning power from a fuel additive, you must look for products containing high concentrations of polyethylamine, universally known in the industry as PA. This is the holy grail of automotive detergents found in premium products like Gaumont Regine or Chevron Techron. The hack is to use 2 bottles and a half tank of gas and drive the vehicle aggressively. Unlike PIB, pale oil, or naphtha, PA is a highly advanced thermally stable nitrogen-based detergent. It is the only cleaning chemical legally verified by automotive engineers to completely survive the violent explosive heat of the combustion chamber. When you inject a high concentration of PA into the engine, it cleans the fuel injectors perfectly. But because it survives the fire, it exits the engine block entirely intact. It travels down the exhaust manifold as a highly active superheated chemical vapor. When this vapor strikes the front face of the catalytic converter, it aggressively attacks the carbon and phosphorus bonds, glazing the ceramic honeycomb. It acts as a chemical scrubbing brush inside the exhaust music pipe. Because PEA is so incredibly stable, it continues to break down hard carbon deposits throughout the entire length of the exhaust system. I had a customer with a Subaru Outback that was burning a quart of oil every 1,000 hours. The burned oil completely glazed his catalytic converter, triggering a permanent P0420 code. We fixed the oil leak, but the converter was still choked. I instructed him to run a double dose of a pure PEA additive. The thermally stable detergent survived the combustion chamber, washed over the ceramic grid, and slowly stripped the baked-on oil glazing away. The code cleared permanently. PA is an incredible tool, but it requires a carrier fuel to travel through the engine. To get pure cleaning power into the exhaust, we must turn to modern aerosol technology. Number 5, liquidly catalytic system cleaner, aerosol. German chemical engineers recognized the limitations of fuel tank additives. They understood that diluting a cleaner in 15 gallons of gasoline drastically reduces its potency. To solve this, they engineered a method that delivers pure, unadulterated chemical cleaners directly into the air intake stream using an aerosol pressure can. The hack requires you to locate the intake throttle body on your engine. You loosen the metal clamp and pull the rubber air intake hose back slightly. You take a can of liquid catalytic system cleaner, which features a long, flexible plastic wand. You insert the wand past the throttle plate. While the engine is running at a steady 2,000 revolutions per minute, you slowly spray the aerosol cleaner directly into the intake manifold. Because you are bypassing the fuel, tank completely, the engine ingests pure, concentrated chemical solvent. This specific German formula is engineered to vaporize instantly. It travels through the combustion chamber and enters the exhaust system as a highly dense active chemical fog. This fog coats the entire surface area of the catalytic converter grid. The concentrated chemicals break the structural bonds of the soot and heavy metal glazing. Because you control the spray rate, you can sustain this chemical fog for 5 to 10 minutes, providing a continuous, aggressive scrub of the internal ceramics. This method is highly effective, but it requires extreme caution. If you spray the aerosol too quickly, the engine will stall. If you spray it directly onto a sensitive mass airflow sensor located before the throttle body, you will destroy the delicate heated wires inside the sensor, causing hundreds of dollars in damage. Aerosol intake cleaners provide concentrated chemical delivery, but they lack the physical mass required to shatter deep, hardened carbon blocks. For that, we must turn to the most powerful tool-free element on Earth. Number 4, water vapor, decarbonization. This is a legendary old guard mechanic trick that relies entirely on physics, rather than retail chemistry. The hack involves taking a spray bottle filled with pure distilled tap water and introducing it directly into the running engine. You remove the main air intake hose, exposing the throttle body. With the engine fully warmed up and running at a steady 3,000 revolutions per minute, You miss the distilled water directly into the intake manifold. The mechanical reaction is violent and incredible. When the microscopic water droplets enter the blistering hot combustion chamber, they instantly flash boil into high-pressure steam. This sudden explosive expansion of steam acts as a pneumatic hammer. It physically shatters the hardened carbon deposits, encrusting the piston crowns in the combustion chamber walls. But the true magic happens in the exhaust stream, when the superheated steam exits the engine and strikes the extremely hot catalytic converter. A precise chemical reaction occurs known as the water-gas shift reaction. At high temperatures, the water vapor reacts with the solid carbon soot trapped inside the honeycomb. The oxygen from the water molecule binds with the carbon, creating carbon monoxide and hydrogen gas. You are literally using plain water to molecularly strip the carbon out of the exhaust system. As you miss the water, you will see massive clouds of black and gray soot blowing forcefully out of the tailpipe. The danger is absolute. If you pour the water instead of misting it, the engine will hydrolock and shatter its internal components. It requires a steady hand and extreme patience. Music. Steam cleaning utilizes thermal shock, but the next method utilizes specialized heavy metals engineered specifically for emissions testing. Number 3, music, CRC guaranteed to pass emissions formula. When drivers are facing an immediate state-mandated emissions test, music failure, they panic. They do not want to risk spraying water into their engine or pulling vacuum lines. They need a simple pour-in solution guaranteed to lower their tailpipe emissions for the test. The hack is to use a heavily concentrated formula like CRC guaranteed to pass. This product is unique because it is not just a standard detergent. It is engineered specifically to temporarily supercharge the catalytic converter's efficiency. A catalytic converter relies on 3 precious metals: platinum, palladium, and rhodium. Platinum and palladium trigger oxidation reactions, turning unburned fuel and carbon monoxide into harmless water and carbon dioxide. Rhodium triggers a reduction reaction, tearing apart toxic nitrogen oxides into harmless nitrogen and oxygen gas. When these metals are glazed, the reactions stop. The CRC formula contains incredibly aggressive, highly concentrated cleaning agents blended with proprietary combustion modifiers. When you pour this into the gas tank and drive until the tank is empty, the chemicals relentlessly scrub the precious metals inside the converter, exposing the platinum and rhodium back to the exhaust stream. The drawback is that this is often a temporary fix. It forces the catalytic converter to operate at peak efficiency for the test. But if the engine is still burning oil or running rich, the converter will simply glaze over again within a few months. To permanently fix the glazing, you need to alter the way you drive, which brings us to a specific protocol borrowed from the heavy diesel industry. It dumps raw fuel into the exhaust to create a massive superheated fire inside the filter, incinerating the soot into fine ash. Gasoline vehicles do not have an active regeneration mode. However, you can manually force your vehicle into a similar state of passive regeneration without using a single tool or chemical additive. This hack relies entirely on manipulating your transmission and exhaust gas temperature sensors. When you drive normally, the engine computer constantly attempts to keep the catalytic converter at a safe, moderate temperature to extend its lifespan. If you want to burn off heavy glazing, you must force the computer to abandon fuel economy and prioritize extreme heat. You must find a long, steep highway incline. You manually shift your automatic transmission out of overdrive and lock it into third gear. You drive up the incline, maintaining a speed of 60 mph. This places a massive sustained load on the engine. The engine computer recognizes the heavy load and the high RPM. It responds by enriching the fuel mixture slightly and advancing the ignition timing. This specific combination of high load, sustained RPM, and enriched fuel creates a massive surge in exhaust gas temperature. You hold this exact gear and speed for 10 continuous minutes. The catalytic converter temperature will safely climb from 500 degrees to nearly 800 degrees C. This sustained intense thermal heat acts like a self-cling oven. The baked-on sulfur, phosphorus, and carbon glazing physically cannot survive at 800 degrees. It incinerates and blows out the tailpipe. A customer with a V6 Toyota Highlander lived in a flat urban environment and continuously triggered P-0420 codes. I told him to take a weekend trip to the mountains. I instructed him to hold third gear up a massive 5-meter mountain pass. The extreme sustained thermal load acted as a natural forced regeneration. The heat burned the converter perfectly clean, and the code vanished entirely. Forced regeneration works brilliantly, but it requires a mountain pass and heavy music loads. What if you could combine the exact thermal science of regeneration with the ultimate chemical detergent, regardless of where you live? Number 1, the 20-minute Japanese thermal phase protocol. This is the ultimate uncompromised tool-free hack. It is a highly specific 20-minute driving protocol developed by analyzing the exact thermal operating windows engineered by Japanese automakers like Honda and Toyota. It combines the aggressive, thermally stable chemistry of pure polyethylamine P with a meticulously controlled heat cycling driving pattern designed to trigger a superheated oxygen wash inside the exhaust. When you simply drive fast, you heat up the catalytic converter, but you also starve it of oxygen because you're burning a massive amount of fuel. A catalytic converter requires excessive oxygen to actually burn the carbon away. This Japanese hack manipulates the engine computer to provide both extreme heat and massive bursts of pure oxygen. Step Music 1 requires preparation. You wait until your vehicle has exactly 1/4 tank of gasoline. You pour in a double dose of a premium pure P-fuel system cleaner. This creates a hyper-concentrated chemical solution that will survive the combustion chamber and soak the exhaust system. Step 2 initiates the thermal phase. You merge onto an open stretch of highway. You manually lock your transmission into a lower gear, usually third or fourth, to maintain exactly 4,000 revolutions per minute at highway speeds. You hold this steady, sustained RPM for exactly 10 minutes. During this 10-minute phase, the hyperconcentrated PA is traveling through the engine, striking the glazed ceramic honeycomb and weakening the chemical bonds of the carbon and phosphorus. Simultaneously, the sustained 4,000 revolutions per minute safely elevates the internal catalytic converter temperature to its maximum safe operating threshold of roughly 800 degrees C. You have now chemically soaked the carbon and baked it to the point of structural failure. Step 3 is where the magic happens. This is the oxygen wash. After 10 minutes of sustained RPM, you completely release the accelerator pedal. You take your foot entirely off the gas, leaving the transmission in gear, and let the vehicle naturally decelerate on the highway. When you completely lift off the throttle at high RPM, modern engine computers initiate a protocol called deceleration fuel cutoff. The computer completely shuts off the fuel injectors to save gas. However, the engine is still spinning rapidly, acting as a massive air pump. Because there is absolutely no fuel entering the engine, the cylinders pump massive volumes of cold, pure, unburned oxygen directly into the blistering, hot exhaust manifold. When this massive wave of pure oxygen strikes the superheated, chemically weakened carbon inside the catalytic converter, a violent, spontaneous oxidation reaction occurs. The oxygen violently rips the carbon molecules off the precious metals, instantly turning the soot into harmless carbon dioxide gas. You let the vehicle decelerate for 10 to 15 seconds, allowing the oxygen to wash the converter completely clean. Then you accelerate back up to 4,000 revolutions per minute for another minute to reheat the system and lift off the throttle again to trigger a second oxygen wash. You repeat this, accelerate and lift cycle 3 music times. A young engineer brought me a high-mileage Lexus IS250. The dealership quoted him $2,500 for a new catalytic converter. He was desperate. I instructed him to execute this exact 20-minute Japanese thermal phase protocol. He added the P, drove the sustained thermal phase, and executed the violent deceleration oxygen washes perfectly. The combination of the chemical detergent weakening the carbon bonds, the extreme heat baking the glazing, and the sudden influx of pure oxygen completely restored the chemical efficiency of the internal ceramic honeycomb. The precious metals were exposed once again. His check engine light turned off. He passed his emissions test the very next morning, and he saved thousands of dollars without turning a single wrench.